I want to tell you and share with you a little more about what I'm learning here at the Steamboat Weather Summit. I want to bring in Dr. Leigh Orf. He is an atmospheric scientist with the University of Wisconsin. Your research and what you shared with us yesterday was so dynamic and so interesting. Let's talk about tornado genesis, because that is the very question we all want to know. Why do tornadoes form? Tell me how you're going about this differently.
Sure, Jen. I am using supercomputers to simulate storms at very high resolution. That means the model can actually capture the swirling flow that precedes the tornado formation. It turns out in these models, when you run them at high resolution, you see detail that you had no idea existed. And it turns out some of this detail actually exists in the real atmosphere, and we can see that. So what makes my work interesting, or what I've done that's sort of different than other folks, is I've managed to find a way to deal with the massive amounts of data that these models produce. I'm able to save the data and then make animations, visualizations of the data, put it in motion, and then I can sit back and go, okay, so that's what's going on in the model. Now let's go look to the atmosphere and see if we can find what's in the model.
Yeah, and you went back and you compared the model data to actual storm supercells that produce tornadoes, and you were able to see things in the environment before the storm created a tornado.
Yeah, and that's what we're looking for. That's the big thing we want to have in meteorology, is the ability to see something on radar that is a symbol that the likelihood of a tornado is very likely, or maybe even a symbol that tells us, oh, this storm is getting weaker, it's probably not going to produce. We want to reduce the false alarm rate. We want to make sure that when people hear the tornado sirens, it's a real tornado and they take it seriously. That's a big focus of the research that I do. Ultimately, we want to lower the false alarm rate.
Yeah, this is a question meteorologists have all the time. Why does one supercell that exhibits rotation drop a tornado than compared to another?
That is the main question that drives my research. And one of the ways to do that is just to simulate a whole bunch of storms in very similar environments, and then look at the ones that produce tornadoes, look at the ones that didn't, and look at what's different between them. That is what we're doing, and this is going to help forecasting in the future. I really believe this. 10, 20 years from now, I think we're going to be able to forecast where tornadoes are going to go with much more precision than we do today.
So it continues to come on down. We're going to bring in Dr. Leigh Orf from the University of Wisconsin. Come on in here. He was one of our speakers this morning. He did a great job, by the way. Your specialty, severe weather tornado forecasting. Finally, here in Las Vegas, the monsoon showed up. Yes. Wettest monsoon in 10 years. What could be the driving factor? All of a sudden, we had less than 10% of our normal rainfall until the monsoon.
The oceans are getting hotter. Climate change is kicking in. Sometimes it's more wet monsoons because there's more water vapor in the atmosphere, more thunderstorms, heavy downpours. Sometimes the high pressure rolls in, drought. So you may see these seesawing events that are due to climate change and heating oceans and a warmer atmosphere.
And I told you earlier when we were talking, Lake Mead responded to our summer rainfall, which is almost 50 inches in about a month. Now, of course, all the snow, we're hoping for that upper Colorado River Basin to feed into Lake Mead. We don't want to lose that due to evaporation, so we don't want it to warm up. But we had an unusual event in Las Vegas and in parts of Arizona. We had 2 tornado warnings in late August. One verified, it was an EF0 in the Meadview area. So is this something we could see more of, given the fact you talk about climate change?
During your big monsoon years, you're probably going to see more tornadoes simply by virtue of the fact you have more thunderstorms and there's more water vapor in the atmosphere, and water vapor drives the thunderstorms. It's the fuel for thunderstorms. Tornadoes are pretty rare in your area, but you'll occasionally get things lined up to get a land spout or a very weak, short-lived tornado. I wouldn't start building storm shelters everywhere in Arizona because of this. That's more for the southeast. But yeah, you may see more tornadoes, but I would worry more about drought and floods.
Drought, and we expect that. We do live in a desert, but these swings of going 10 years with nothing, and then all of a sudden we pick up almost 2 inches of rain, so we could expect more than that.
Yeah, that's pretty clearly climate change driven, because I've been studying this since I was a grad student in the 90s, and this is kind of what they forecast.
All right, Dr. Leigh, thank you so much. I really appreciate it. Good work today. All right, we're going to send